Hello, here's an example video. There's a lot of homework questions like this, so you probably want to pay attention to this one because this is going to help you with about half of the homework problems, or the same kind of thing as this. So let's see. If you kick a rock off the rim of the Grand Canyon, its speed is v. That will vary directly with the time t it has been falling. So let's just translate that part first. When it says that its speed v varies directly with the time t it has been falling, that means you can write an equation in the form v equals k times t for some constant number k that doesn't change even as t changes. Okay, so and it also gives us some more information. The rock is falling at a speed of 39.2 meters per second. So that's a value of v that it gives you when it passes a lizard on a ledge 4 seconds later. I guess the lizard had like a laser gun to a thing that cops have. What do you call those? Speedometer? I don't know. To tell exactly how fast the rock was going as it passed by the lizard. So we got that. We got a value of v equals 39.2 meters per second when t equals 4 seconds. So then let's look at question A. Express v as a function of t. This is another way of saying write an equation for v in terms of t. So to write an equation for v in terms of t means the same thing as express v as a function of t. In other words, v equals f of t, and we just got to figure out what this expression is. So what do you plug t into that results in v? Oh, but hey, we know we have something because it's a direct variation. We can write v equals k times t. And let's do the k in green just because. But we just need to figure out what the k is because it's not really a complete equation right now. If I know what t is, it doesn't actually tell me what v is if you don't know what k is too, because you need to multiply two numbers together. So we have to find the value of k that makes that work. So how do you find the value of k? Well, it gives you these two values here. So we can say that if we plug in 39.2 for v, the k is still unknown, and the t is just going to be the number 4. We can find what value of k works for that one point, and if it is direct variation, it needs to work for all the other values of v and t as well. So you can just divide both sides of this by 4. And then let's see, what is 39.2 divided by 4? It's 9.8, so we can say that 9.8 is k. So now we can actually write the formula that actually, once you can just plug in t and it will tell you what v is. So we can say v equals f of t, if you want, equals 9.8 times t. And you could write it either this way, or of course it means the same thing as you just write v equals 9.8 t, or you could just write f of t equals 9.8 times t. Those are both fine as well. Okay, now let's see what B is asking. What is the speed of the rock after it has fallen for 6 seconds? Well, the question is asking to find v when t equals 6. So you can just plug in t equals 6 into the formula here, and the result is going to be v equals 9.8 multiplied by 6. I think I can do this in my head. I think it's going to be 58.8. Yes. Okay, so that's the answer to that. After 6 seconds, it's going 58.8 meters per second. Now let's sketch a graph of v versus t, and we're going to see something that's generally true about direct variation graphs here. I just set up the axes to speed things up. So let's graph the 2 points we have. We know one that was given was when t is 4, v is 39.2. So that's going to be about here-ish. And the other one is 6, and then a little bit under 60, which is going to be here. So we've got those points. And here's another one that you could find really easily. I mean, you could just plug in a bunch of values of t. An easy one to do arithmetic is if you plug in t equals 0, then v will also be 0. Because 0 seconds after it was dropped, that's right when you're letting go of it, so or right when you kick it, and at that moment it hasn't moved at all. So it's gonna have that point. And the other thing about this is that when we're graphing v equals 9.8 t, this looks like y equals mx plus b format. It's just that the 9.8 is the m, and what is the b? The b is 0. So we can think of this as just a line with slope 0, slope 9.8 and y-intercept 0 right here. So let's try to draw that line. Whoops. And my grid's not perfect apparently. Let's pretend that this point is a little bit over here. Okay, so if I had perfect graph paper, maybe that would have come out a little bit better. But yeah, it should be a straight line with slope 9.8, y-intercept 0. And that's true about direct variation situations in general. They're always going to be a line through the point 0, 0, and the slope is just the same thing as the constant of variation. Okay, now next here's an exercise for you to do. This one you're definitely going to do it yourself. The way to do it is really similar to what I did for the last one. So part A is similar to the example 3 part A, and part B here is almost the same as the example part B before. So it's a good thing to just practice the terminology. All right, good luck with that, and I'll see you in the next video.